Okay, so here we go. The atom. We now know that the nucleus contains the protons and neutrons. We now know that we can take the atomic mass minus atomic number to find our number of neutrons. We know that the nucleus is positively charged. It's the most massive area. We now know that the electrons are on the outside of the nucleus and they're not running these tracks. Okay? All of this is based on math, and you basically had a bunch of guys during the 1900s who all got together and they discussed this. And they finally figured out that basically when you're dealing with electrons, you have a mathematical probability of finding them in a certain area, a certain region. And they also figured out that the reason you get a magnetic field or electromagnetic field produced with atoms is that your electrons are actually spinning on their axis just like the moon or the earth is spinning on their axis. So in some ways Rutherford was on the right path, but he just quite wasn't there. Okay? All right, and part of the evidence we get for this is from Erwin Mueller, who took crystals and cut them into thin pieces, and then he shot x-rays through them. And he produced these images that you see here. And you're probably looking and going, okay, they're really kind of pretty. But when he looked at it, he thought to himself, there's got to be a mathematical relationship here. There has to be some math that supports this idea that I'm seeing here. And because of that, they were able to figure out that there must have been a shell. Okay, and a shell is nothing more than a general region of electron movement around the nucleus. And basically our electrons stay in those regions until they get excited. And once they get excited, they move from one region to the next. So when we take the electricity and we push electricity through the emission tubes, we excite the electrons and we get a light being given off. When you take the Bunsen burner and you light the popsicle stick, you're going to excite the electrons. And we'll use a diffracting gradient to break up the light that those electrons emit so we can figure out what we're dealing with. Okay, and each cell is a specific region or specific distance, and this all relates to the periodic table. And orbitals are passive, electrons go within the shell. And all this came because of evidence like what Erwin Mueller produced and others. Wolfgang Pauli is a very important individual. He's one of those gurus who met during the 1900s to discuss this, along with Bohr, Schrodinger, Einstein, some major players in physics. And Wolfgang Pauli gave us the idea that electrons spin and they revolve. Okay, and that the spinning creates a magnetic field. Electrons that spin opposite from one another are attracted to one another just like magnets. Oh, so what I've learned in physics, I apply forward. Yes, exactly. And so we know this as Pauli's exclusion principle, which he came up with in 1925, that no more than 2 electrons can occupy the same orbital. Now, I want you to look at your periodic table. You'll notice that we have even numbers. 2, 10, 6, 14. Huh, isn't that amazing that all those are in even number blocks? It all relates back to Wolfgang Pauli in his idea. So, each atom has one or more shells depending upon the number of protons and electrons that are there. And when we talk about shells, oh yeah, there's the periodic table again, we're referring to the rows. Every time that I go down a row, I'm adding another shell. Okay? Orbitals are limiting. There's only a certain number of electrons that can fit into an orbital. Okay? So we think about this. We're drawing out our atoms and stuff. And I told you that the first row you can only have 2. You can only have 2 because of these 2. There's only 2 blocks in the first row. So only 2 electrons can fit there. When I look at the second row, we talked about an octet, that the noble gases have octet in order to be noble. You had to have an octet. Well, where did I get octet from? Take 2 plus 6 and you get, bam, 8. Oh. So, what's that about the transition metals? Well, we're going to skip them for now, but there is something to do with them as well. Okay? So when I look at that, these are another way of modeling different elements. And there's an even pattern among them. Niels Bohr developed a theory that electrons revolve in definite energy levels called quantum theory. Okay. I love this image that one of my professors gave us. He said classical theory is like a ramp. Okay? So this is classical theory. This is what Rutherford came up with. And so my little electron can go up or down the ramp however it wants to do. But Bohr said, no, that's not right. That's not the way it works. He said instead there are packets of energy. So if you think of a set of stairs and we have our little bitty electron here, the only way that he can get to the next level is he has to have a little bit above that step. If he has a little bit above that step, then he gets to go to the next level. Okay? The only way he gets to go down is he has to lose enough energy to go to the next level. So, this is quantum theory. And quanta refers to packets of energy. Packets of energy. Okay, I'm going to leave you there.